right. Thanks for listening while we take that short break here at Revolution Radio, freedomslips.com. And now we're going to get back to your host.
Ladies and gentlemen, welcome back to another episode of Cosmic Catastrophe on Revolution.radio. And my mic is on.
Good job. And you got the right one.
We got a great show. I don't know why it was set correctly.
Yeah, sometimes mine's set correctly and sometimes it's not.
Interesting.
I think it depends on what state the microphone is in when you start Skype.
Gotcha. So we have a great show for you today. We're going to be talking about all of the most interesting science topics over the last week or so, including, and we're going to kick it off discussing more fear-mongering about the Great Barrier Reef and an article coming out about catastrophic coral bleaching. We will destroy that in just a matter of minutes. We'll then jump over to some 350,000-year-old footprints that were left in volcanic deposits over in Italy, and we'll discuss what hominid might have left them. And the second half of the show, we're going to be talking about some structural geology. We were all taught, if you ever took a geology course, about that nice little cross-section of the Earth. It looks like a gobstopper with perfect little layers in there. Well, the more and more seismographs that get put up on Earth, the more data we have of what actually is inside of the Earth, and it's nothing like the picture. Mm-hmm. And finally, if we have time, we'll talk about some giant glacial features that were just discovered at the bottom of the North Sea and what those implications may be, because I hope you put it together. You and I have talked about that weird ice age transition about at least a half a dozen times. Mm-hmm. Yeah.
I was actually amazed that this media article even mentioned it.
That what article?
There's a media article about the glacier.
Oh no, it begins, ladies and gentlemen.
Oh, you're frozen for me.
Yep, it's already happened.
Oh, gosh.
So let me know if you can see the screen.
Yeah.
Here is the article coming from Oceanographic. Coral bleaching on the Great Barrier Reef reaches catastrophic levels. Now, the first thing you want to question when reading that title is, what are catastrophic levels of coral bleaching?
Right.
If you don't know, and maybe even the authors of this article didn't know, coral bleaching is a stress response. An individual coral colony suffers from a degree of bleaching at any given summer. It is a natural process, and it is of no particular concern because it is a process of reef building and breaking. So large-scale marine heat waves can create mass coral bleaching events. However, in which large numbers of corals bleach severely over a wide area, like the Great Barrier Reef. Now, the reason there's large coral bleaching events is because the reef is gigantic. So we're going to have sections that are more prone to these bleaching events, maybe that are closer to sea level or whatever it is. And as corals are bleached, new corals are replacing them.
Oh, and not only that, but even in the study that is associated with this claim of catastrophic levels of coral bleaching, in the study, at the end of the study, they say, when the coral dies and then it breaks down, it creates fragments of coral. And it says these new coral fragments will contribute to sedimentary environments in island dynamics and reef flats. The reef to rubble phenomena is a major driver of transformation to new tropical ecosystem. I'm missing something in the sentence here. States that, The reef to rubble phenomena is a major driver of transformation to new tropical ecosystem states that are difficult to recover from and needs urgent attention. So they're acknowledging that there's some kind of environmental transformation. In other words, something dies and something new is created. And then they're like, oh no, this can't happen.
Well, we're
Says
looking
you?
at
I mean,
right. We're looking at it right here on the cover photo. So
Yeah.
if you can see here off to the right side, there's a reef away from this island. Let's say there's a coral bleaching event at the reef. It breaks down. The wave action here causes it. Take a look at the island to be deposited here on the backside,
Mhm.
which allows more biodiversity on this island to commence.
Right.
So it's growing this tropical island in a particular direction.
Right. Well, and obviously there's going to be nutrients deposited as well, like calcium, for example, which is what coral is made of largely. Like, so this is, I mean, the problem with this is they looked at a certain section of reef for 100 and whatever it was, 161, 164 days. They saw, major areas of coral bleaching, and they said, oh no, this is terrible. And it's like, okay, wait, hang on a second, because in order to determine that it's catastrophic and terrible, you need to compare that period of time with what has happened with coral reefs over a very long period of time. If you're going to say it's catastrophic, then you need to know what the normal pattern is when there's not something catastrophic happening.
Right. Excellent. So let's go check that out. But first, before we see if this actually is catastrophic, let's talk about some mass coral bleaching events that have happened on the Great Barrier Reef. There have been many of them. There was one in 2016, 2017, 2020, 2022, and 2024. This is the catastrophic one they're discussing. If this were the case, you would assume that the Great Barrier Reef is shrinking and dying like they've been claiming, correct?
Mm-hmm. Right.
Unfortunately, the data is the exact opposite. If you come over to the actual measure of coral reef that's alive, 2023 and 2024 were the highest coral cover on the Great Barrier Reef in the last 35 years. So,
I mean, it's like, okay, one of the things that our wildlife, state wildlife department or whatever does here is, they monitor the populations of, say, mountain lions and deer, right? So if we were to suddenly see an explosion in the population of deer, we would start the mountain lion population. So there's a symbiotic relationship that also happens here with the coral reef. When the coral reef is subjected to heat, to hotter water, it has a relationship with a symbiotic organism that causes it to die. So my point is that when we see a shift, let's say in the mountain lions and the deer, we don't wonder like, oh, is it because of anthropogenic global warming? We instead look to what is the relationship between these organisms? What are the natural relationships and the natural cycles that might be causing this? You don't you don't assume that it's automatically assume that it's catastrophic. It doesn't make any sense. There's so many other variables that go into an ecosystem like this and the shifting dynamics. So without looking at that as a whole in entirety, the conclusion of 161 days of study doesn't mean anything.
No, especially when you look at the coral cover graph right here we're looking at.
Right. Because this is the larger context.
Yeah, the lowest measure of coral cover in the last 35 years was after a major cyclone, Cyclone Hamish. And since then, the recovery at the reef has been exponential. It has gone up, look at this, vertically almost, compared to the past.
Right. Despite catastrophic, so-called catastrophic losses.
Right. They're blaming the bleaching on warming too. And you can clearly see here this point, this giant point of regrowth of the reef corresponds to the warmest time, the biggest El Nino spike we've had back in 2016.
Right.
So this is a warming causes the reef to recover, not the opposite.
Right. Well, and it's also as if these people assume, no, it's as if they've forgotten that part of life is death. Things die. Things need to die for life to continue. They seem to have forgotten that here. It's very strange.
So what do you think? Is it catastrophic bleaching or what?
Well, I mean, based on the larger context of overall growth of coral reef, obviously not.
And maybe, in fact, if they did the correct study, if we have these instances of catastrophic bleaching, it may be indicative of coral reef growth as a whole.
Well, that could be the case as well, right?
So I think they really need to do some actual scientific studies here instead of the propaganda that's being fed.
Well, and it's also very clear to me that this study was done in response to funding that favors the global warming narrative because of the way that the study ends. I mean, they literally end with a sentence about, oh, we have to take action now and reduce emissions because this is terrible. And it's
right.
like
The Great Barrier Reef has never been better. That's
right.
all.
Right. I mean, and it's like, okay, are these people aware of this data that we're looking at right now? Or are they willfully ignoring it, or are they just not seeing it? It's one or the other.
There could be some reasoning for that. There could be not that smart scientists that don't really study the reef as a whole, because what they did was compartmentalize the reef about a decade ago, where there used to be this data set, which is a composite of all of the reef as a whole. They've now broken it down into 11 reef sectors.
Right. Well, and that is clearly part of the picture here in this paper because they only looked at very specific areas.
Yeah. So if you want to look at the technical details, there's even reef monitoring maps here that are very high resolution that you can come and look and see how amazing the Great Barrier Reef is actually doing.
Right.
Yeah. So we'll leave you links to all that below. Anything else you want to talk about on the Great Barrier?
Nope.
All right. So sticking with headlines that are nonsense, here's another one. Who were the quote unquote devil humans who walked on volcanic debris 350,000 years ago?
Mm-hmm.
What are your thoughts on that title?
I don't know why they're putting the word devil in there. I mean, they obviously that it was inspired by the idea of how did these people walk on volcanic debris? Wasn't it too hot? And then they very quickly kind of dismissed that, like, well, it obviously cooled enough for them to walk on it. So why are you calling them devils?
Yes, because they're walking on the hot lava.
Right. It's just silly. I mean, it's obviously meant to be a bit of a splash.
Yeah, it is IFL science, by the way. All right.
But apparently the devil is...
Go ahead. Of course, you froze up now. All right, I'm going to read it. Around 350,000 years ago, a now extinct volcano in southern Italy violently erupted, spewing ash into the atmosphere and filling a nearby valley with molten pyroclastic material. As this hellish discharge cooled, a mysterious group of ancient humans went for a stroll along the newly formed volcanic terrain, leaving behind a trail of footprints in the soft rock. Dubbing these prehistoric prints devil trails, a team of researchers has now analyzed the tracks, and they discovered the height and weight of the people that made the depressions.
Mm-hmm.
And that turned out to be 132 pounds and about 5'3". And that just happens to match up with an ancient hominid that was around there at the time that had a pretty big brow ridge. Look at that.
Yeah.
This is Homo heidelbergensis. And this is a reconstruction of what they may have looked like.
Why do they always make the ancient hominids so hairy?
There's one reconstruction where the facial hair is like just sparse, like an Asian. And I'm like, how did they?
Right. But there's this, there's this caveman image that they seem to feel the need to always fulfill. I mean, granted, I understand that it's, I suppose, who knows? I mean, were men shaving? I don't know, but this
I don't
guy's
think
really hairy.
350,000 years ago, Homo heidelbergensis was shaving.
Well, maybe. I mean, these people used tools and sharp blades. I mean, maybe they were.
Well, yeah, there's a huge cache in a Polish cave that we discussed on this channel that they link to heidelbergensis because the tools were in situ with the skeletal remains. And the technology 500,000 years ago that these hominids were using is the same as Native Americans were using 500 years ago.
Right.
Pressure flaking, we got drill cores, scrapers. So
Which
who's
is
to
another
say
reminder.
They might have been shaving. This could have been their shave kit.
Right. And that, the existence of these tools 500,000 years ago is again a reminder that there's really no reason to assume that there's some sort of progressive linear evolution of the intellect of hominids, right? Like it appears that our intellect hasn't really changed very much.
Well, one study I did see shows that these earlier hominids, and the earlier you go back, if you go back like 3 million years to Australopithecus or something like that, they were mostly non-meat eaters.
Right.
And they had tiny brains. So something happens where we're getting into these type of hominids where they are eating lots of marrow, animal fats, and the brain capacity is increasing.
Yeah. Yeah. Well, those things, the fats and the meats are...
Let me finish the thought.
Okay.
So what happens here, this is almost 500,000 years ago. And then we've got all these lineages we're discovering. We don't know all of them, just a portion of them between this time and now. But the culmination is Neanderthal with the biggest cranial capacity. And this is occurring after 60,000 years of super ice age conditions where the only thing we're probably eating is animals. Yeah, there's not a lot of plants and fruits around when it's that cold.
Yeah. I think it's often unrecognized that animal protein and fat is extremely nutrient dense, and especially things like marrow, that there's a real benefit to eating those things. There's a reason why we've been eating those things for millions of years.
So this guy was running around Italy 350,000 years ago, and maybe it was a little chilly out, but when he walked across this squishy surface, he was like, ooh, that's nice.
Right.
But what is more important is that this type of eruption in Italy shows a pattern. We know that Italy has the potential for super volcanic activity. And so this is a danger that humanity lives with every single second, every day of the year. That an event like this could happen.
It does make you wonder what the reason was for walking over the volcanic debris.
Maybe escape. That would be what I would thinking. Escaping the situation, and that's the only way to go.
Right. I mean, it does seem a bit risky, right? Like you probably don't know exactly what you're going to encounter on the way because it's not as if all of that material is going to be the same temperature or in the same state.
Yeah, when the way these depressions look, maybe they had their feet in moccasins or something. There's not like toe prints or anything. And you did freeze up, so let me know when you're back. All right, there you are.
Need our bandwidth back.
What is happening? Yeah. So we'll leave you links to all the papers about Homo heidelbergensis, including those cave finds in Poland, frontiers of the lower Paleolithic expansion in Europe, Tunel, Wielkie Cave. I actually knew how to pronounce that when we did the show. All right, onward and upward. The strange blobs found deep inside the earth where no such blobs should exist.
Mm.
There's another one of those
Should.
titles.
To say should is like that's an assumption that we know what the inside of the earth is supposed to look like. We clearly don't. I mean, it's kind of hilarious, right? Because we have such a lack of understanding, not only of the interior of our Earth, but also to some degree of the deepest parts of the ocean. You know,
Right. We
we
haven't
really
even
have quite a
been
lot
there.
to
We've
learn.
barely drilled into the crust, for goodness sakes.
Right.
And so this is what everyone assumes the earth looks like because they put it in a textbook in 1972 and it hasn't
Mm-hmm.
changed.
Mm-hmm.
So that's why they're saying these blobs shouldn't exist.
Mm.
When in reality, they should be saying, and we've said similar things about similar topics, that their hypothesis is probably incorrect and it needs to be changed.
Mm-hmm.
Yeah. So the general structure of the Earth, what we know based on early seismic data. So when seismic waves travel through the Earth, we can measure changes in speed. And early seismographs were able to delineate an inner and outer core and crustal and asthenosphere boundaries, which gives us, where is it? The pretty picture like this. So
Mm-hmm.
early on, with limited data, this was a general idea of what the Earth may look like based on the speed of seismic waves moving through it. But since then, we've discovered many strange things, including LLSVPs. And this is because we're using more and more seismographs in more places. We start to get a really good picture of what's going on inside of the Earth. And maybe a decade ago, we discovered these large, low shear velocity provinces, which at the time, guess what they said? They shouldn't be
be
there.
there.
So we have no idea what these are. They're highly asymmetrical, and they happen to be lined up right now at the equator.
Mm-hmm.
And the idea is somehow maybe these can shift, and then that would cause the Earth to shift into a different rotational position.
Mm.
That's part of the catastrophic crustal slip hypothesis.
Mm-hmm.
That somehow these things can shift, and then the Earth, they have to be here where they are right now because of you know what I'm saying? The distribution of the densities.
Yeah. Yeah.
And so this is the older data. And now we've got this new data coming in from this new study. Full waveform inversion reveals diverse origins of lower mantle positive wave speed anomalies. That's a mouthful.
Mm-hmm.
So here is a good picture where we know that there's those two giant blobs that are attached to the core mantle boundary, let's say.
Mm-hmm. Mm-hmm.
They may be emanating from the core, right? Those red blobs,
Yeah.
they may be leaking out of the core.
Mm-hmm.
As the Earth grows in size, that may be one of the
Mm-hmm.
reasons. The core is creating these blobs, and they're actually spilling out from the core, and then the Earth has to expand, right? It has to get bigger.
Right. Well, that's the hypothesis we're working with anyway.
Yeah. So now, using even more seismic data, we've got confusion. There is so much going on in the mantle. No one has any idea what any of it means.
Right. In this study, you know, they acknowledge that, you know, some of these quote unquote blobs or slabs that we were aware of previously, I guess not as deep, that they, you know, they tend to line up with subduction zones, both, you know, modern and ancient. But what they found here is that these new blobs that they've noticed in the deeper levels don't seem to correspond particularly to those areas. So, you know, like there's some like under the middle of the Pacific Ocean, for example. So they're like, well, what are these? know that that's the case. And so, but with that, they're trying to, in this study, sort of hypothesize, well, maybe it's related to a period long ago when we still had like Pangea breaking up. Which, as we've talked about many times, has there's some skepticism around that. But, if, as we've talked about with Pangea, one of the problems is it creates a very lopsided Earth as far as the balance of weight and density. So if it's really a function of an expanding Earth, an Earth that was actually much smaller, thus accounting for an oceanic crust that is much larger today than we would expect and younger, then that might explain these. Or it could be the opposite. Like perhaps these blobs are actually rising somehow, although they are determined to be colder than the surrounding area, and that's why the positive wave anomaly picks them up. So we have no idea really, but we can definitely throw some ideas out there.
Yeah, so here is the Telkania anomaly, which is really deep and really close to the core mantle boundary. This is one of those places they're like, what is that? And then the East Pacific anomaly has really no association with the subduction zone. So that's another, what is that?
Right.
But if the Earth has been expanding, the crust has been all over the place and not where we really think it may have been.
Right.
And a blob like this is really, so a lot of these are explained as old subducted seafloor or something because they call them slabs and they appear to be like, yeah, okay, it's a slab there.
Right.
But this is not a slab, it's a blob.
Right.
Well,
and
we
obviously
used to think in the mantle here there were convection currents. It was taught as a geologist.
Right.
So this material could be acting plastic and simply be moving around.
Right.
That's it.
Right. Right. I mean, part of the problem here is that the all we can tell from this is that a blob is either colder than the surrounding area or it's chemically different, but we don't know what they're made of. We don't know what the constitution is, and so that really limits our understanding of what they are.
Yeah, and it's impossible to get down there. I wonder in the future what technology we'll have to figure out the chemical composition of these things.
Right.
It may be some type, it could be some type of super technology that you have to use from a satellite or something that can penetrate the entire planet.
Right.
I don't know what it would be because we don't have it.
Right. Yeah. Yeah. I mean, it's pretty interesting nonetheless. I mean, it really kind of makes you think about a lot of different possibilities about Earth's history. And I don't think that this study alone will have any major impacts on our models of the interior of Earth, but it's an important step in that direction.
Yeah, and what is very clear is that the interior of the Earth is much more complicated than we thought. There are processes at work that we are unaware of and we cannot explain, and that the more technologically advanced we become, the less we know about the interior of the Earth. We know the structure, but that doesn't tell us anything about the processes at work.
Right.
Like, what the heck are these things?
Right. Right. Yep.
Pretty interesting.
Yeah, very interesting.
Anything else you want to talk about on the blobs?
No.
Yeah, we didn't really even look at the images of.
Oh, yeah, we should.
Yeah, so these are the different temperature zones based on changing seismic velocities. And the reason they can image this now, it was like, it's because we get better and better supercomputers. We can do more and more things.
Right.
People are not crunching these numbers.
Right.
So eventually AI will tell us what's going on in Earth. The problem with that is it's just going to make it up based on everything.
Well, and what was it? It was one of the AIs, was it a chat GPT? Just somebody got a chat GPT to recently admit that its functioning is essentially Stalinist in nature because it it is pushing certain narratives, and the AI acknowledged this.
Yeah, that was pretty funny.
I mean, why else do you think that there's an AI answer that pops up at the top of every Google search now? Because that's what's going to happen. People will just read the AI response and trust that.
Oh. You froze up
Talking
on,
and people can hear you. Or oh, there we go.
you froze up on my end.
Yeah, you froze up on mine.
So this has got to change. I got to call Elon right after the show.
Yeah, this has really been a problem. I was having problem with Wi-Fi phone calls yesterday too.
I wonder how the StreamYard will do with our interview on Wednesday.
Yeah.
Oh, so there we go. We got an announcement. We're going to be have Martin Durkin on the show with Tom Nelson to discuss. For all of you that saw the new channel out there, Gorilla Science, with the 5-minute Willie Soon clip, where he takes his coal-powered time machine back to the age of the dinosaurs. You got to check it out. We're going to be interviewing the producer of that and Tom Nelson about their new channel. And so it should be fun.
Yeah.
As well as demonetized.
What else is new?
All right. Any more pretty pictures in this paper?
There's a lot of pretty pictures in this paper, actually, but
oh wow, look at that. So clearly we don't
so
know.
You here, go back up again a little bit. Here's where right here, where they're sort of trying to line up these blobs with like a not a Pangea, but a sort of post Pangea, like as it's breaking up.
But they're assuming these ancient plate boundaries and positions. It's all assumptions anyway.
Right.
Yeah.
So yeah, a lot of it is kind of circular reasoning. So,
and the reality is if we've had all this subduction and there is all of the ancient oceans are missing through subduction, then that's what these slabs would be.
Right.
Because they're like the oldest ocean we have is only 300 million years old. Nothing before that.
Right. But we still have the problem of the fact that, like, especially around the Pacific, that the ocean floor, the size is actually expanding. So we are growing faster than we are subducting.
And maybe the low velocity zones have something to do with that.
Right.
Where was it? There. That could be the way we're expanding, whatever that material is.
Well, that's what I'm wondering about. So, it then brings into question, and I was kind of alluded to this earlier, but I didn't fully express it. If these are being seen by the seismicity because they represent materials that are colder than the surrounding area and we're expanding, then the problem would be that you've got cold material that's expanding out towards the crust of Earth, but that conflicts with the convection idea.
Yeah.
So, which, and of course the convection idea very well may be incorrect. We know so little.
And their assumption may be correct because all we know is that they have extremely low seismic velocities. That's the only thing we know about these blobs.
Mm-hmm.
It could be a material we don't even know about.
Right.
This material is under such temperature and pressure, it may be something we don't have on the surface any evidence of.
Right. Right.
But we don't know nothing.
But, this is also a great example of this thing that we see happening in science all the time, where we're working from a particular sort of model of what we think is going on, and then we find evidence that contradicts that model, and we say things like, oh, it shouldn't be there. And instead of accepting that our model must be incorrect and we need a new one, we're still trying to like shove the thing that doesn't fit back into the model by changing the model. This is very circular reasoning, and it clearly doesn't work. We have this problem in cosmology, we have it in climate science, and we have it here too.
Oh, the poor geologists.
Yeah.
So the Earth is more dynamic and more complex than we ever knew before. And we're just getting dumber and dumber as these breakthroughs come out. For one reason, we're not coming up with any new models to explain it. Like you said in cosmology, they're not really working with any new cosmological models. Now, clearly, EU and plasma cosmology are.
Right.
But it's not really being incorporated into the mainstream science nomenclature. They're still talking about icy frickin' snowballs for comets.
Right, right. Well, in the cosmology department, though, it is pretty interesting, right? Because as has been pointed out recently, especially by the Thunderbolts project, there's now what is being called a cosmological crisis. How the universe when that bubble bursts, right? Because this is a process that we see time and again within science. There's a very famous book that was written about this by Thomas Kuhn. It's called The Structure of Scientific Revolutions. And this is typically part of that process where you have contradictory evidence that builds and builds and builds until the bubble kind of bursts. And then we start over with a new paradigm. And then we hang on to that one for an extensively long period of time.
Yeah, and I remember being taught in grade school that a paradigm shift can take 3 decades.
Absolutely. It takes a very long time.
Yes, indeed. All right, let's talk about some glacial features in the North Sea, and hopefully we won't freeze up too many times.
Yeah.
So deep beneath the North Sea lies a hidden world shaped by massive ice age glacier that once dominated the landscape. Recently uncovered by scientists, these ancient landforms are offering clues to a mysterious climatic shift that reshaped Earth over 1 million years ago. What secrets do these buried formations hold about our planet's frozen past, and what can they reveal about its future? Oh my. Well, take a look at, you could see the graphics if you rewatch tonight. Isn't that true?
That's true. If you can find us tonight on Magnetic Reversal News on YouTube at 8 p.m. Mountain Time.
So here we can see these giant glacial features. And beneath the muddy depths of the North Sea, scientists have uncovered an ancient frozen world shaped by massive ice age glacier, a massive, that swept across the region 1 million years ago using advanced sound wave imaging. The researchers revealed intricate landforms preserved under nearly 1 kilometer of sediment. So they're looking through the mud to see these striations on the seafloor. Absolutely amazing.
Yeah, it's pretty cool.
And they're massive scour marks, which would be indicative of a huge glacier there scratching these into the ground. What's interesting is they correspond to a very specific time in the Ice Age that Leah and I discuss often. The massive glacier existed during the mid-Pleistocene transition. This is a critical period between 1.3 million and 700,000 years ago. And during this time, Earth's glacial cycles underwent a dramatic shift, transitioning from the shorter 40,000 year cycle to a longer and more intense or stronger 100,000 year cycle. Understanding the extent and behavior of the North Sea ice sheet during this period is crucial for decoding the cause of this climate transformation. I don't know if studying this glacier that was here is going to tell us what changed it from 40 to 100,000 years. Do you?
No, I don't think so.
Yeah.
No.
So we've shown
obviously it's worth noting that the transition happens at the end of a major ice age, but I don't know that you can really glean much more than that.
Yeah. So the ice age that we're living in begins somewhere here when the temperatures fall below what we call the modern normal. Some people put it at 2.5 million right here. Some put it like at the end of this spike, 2.3 million. Some put it back here at 2.8 million. But this is when the ice age begins, because large ice sheets form on the northern hemisphere. So there is a threshold of temperature we reached here where we're going to get a polar ice cap now. And it comes and goes on a regular periodicity.
Right.
For millions of years, the first 1.5 million plus years, it was growing and shrinking every 40,000 years. And then something happens right around here, which is that transition. I think I can pinpoint it right there where this huge gap is. Something gets reset in here. Boom, boom. There's a really tiny cycle. And then the cycle becomes 100,000 after that.
Right.
And then you and I noticed that just in the last 400,000 years, the cycle has gotten more extreme. So another shift right here.
Yeah. Yeah. So really those two things didn't transition at the same time, right? The frequency changed, but the amplitude did not initially, but now it really is.
Yeah. And one of the reasons that massive ice sheet might have formed right around this time is that we start to have these extended periods of cold, and it's long enough to form a massive glacier there. The cycles get much longer, and the cooling, look at how much longer the cooling is here than these little spikes. So that is the trigger right here to grow that massive, and it lasts from about here to here.
Yeah.
Right until the 100,000 year cycle kicks back in, that's even more extreme. And maybe it's these interstadials that are too warm for that glacier to remain.
Right. Right. Oh,
It could also
kind
be
of
that when you go from the 40 to the 100, some type of ocean currents shift completely, and that it's bringing warm water up towards Norway here.
Right. So, I mean, we've thrown out the idea a couple of times that, if expanding Earth hypothesis is true, then you could potentially argue that somewhere in this time frame when this transition happened, that we had some, let's say, a burst of expansion on Earth, which contributed to a changing, or ocean current pattern, and perhaps that, helped create a longer cycle and then ultimately a more extreme cycle.
Yeah, I could believe that.
And you're right. I mean, completely speculative and completely just a hypothesis, but it's something worth chewing on.
Yeah, the only problem I have with that is when you're looking at this graph, it appears as if it's something more pervasive and external that's controlling this.
Right.
It's too regular in a sense. It doesn't look like static. Clearly something is very periodic, episodic, and regular for the first 1 million years here. It's like clockwork. The only thing changing is slight amplitude, and we're just talking a few degrees C. What's also funny is the range on here of the change is massive. It's like 16 degrees C, and they're trying to sell you that 2 millimeters on this graph means we're all going to die.
I know. It drives me crazy, right? My father likes to remind me that he likes to ask people, when they start talking about the global warming narrative, he says, well, what was happening, at the end of the last ice age? Did we cause that warming, that extreme change? And like nobody ever has a response for him, right? So it's like if it can happen naturally, which the data indicates that it clearly does, then why do we need a new explanation that humans are the reason, right? Like I was just having this conversation with somebody last week that you can't immediately jump to some exceptional explanation for something when there's a perfectly good explanation already at the ready. Now, not to say that we really have an explanation per se here, but we do have the observation that there are massive shifts in climate that happen on a regular basis that obviously have nothing to do with human beings.
What is pretty telling and very bad for humanity is looking at the last 5 million.
Yeah.
So hominids really kicked off here about 3.5 million years ago, when we entered one of the first, that would be a glacial cycle, but it's not considered in the Ice Age.
Mm.
The Ice Age begins here, but it's still as cold as it is here. So this may kick off hominids, us. Now look what's happening for 3.5 million years. The amplitude of the climate catastrophe shifts in the beginning from just 4 degrees C to today over 12 degrees C.
Right.
And it's growing larger and larger. The last cycle from the Eemian to the bottom of this one is the largest amplitude change of any of these Ice Age cycles.
Yeah. Yes.
So the next cycle, based on this graph, may be even a larger swing.
Right. And we talked about, I think it was last week on our show, we noticed looking at similar graphs that if you look at this compared to periods of higher civilization, it's not so much like we obviously thrive more in the warm periods, but our downfall is not necessarily colder temperatures, it's the drop off from a certain level of temperature. So if things are relatively stable, we do pretty well. And that it's when the big temperature drop offs happen that we really struggle. And so with these temperature changes being so much more extreme, like you said, it doesn't really bode very well for humanity.
Yeah, it's only getting more extreme. And a 1.2 or 3 degrees C change warmer, that's good for us. It's when we drop 14 C that we all move into caves because there's nowhere else to go.
Right. Right. Well, and then for modern day society, it's worse because many times, you can't just pick that area up and move it somewhere else. It's not so easy to adjust when that's how your economy is structured.
Yeah, I agree. Let's talk the bigger picture here. No one's going to be alive to witness one of these types of cycles because now we're on a 100,000 year schedule. And prior to that, it was a 40,000 year schedule. But the question is, we're looking at 60 Ice Age cycles here with interglacial and glacial maximum. This means we have the potential here for 60 advanced civilizations to come and go and be completely erased again and again. And so if anyone is wondering what type of amnesia humanity is suffering from, it is this. It is this cycle. It is not some blip that they're fear-mongering about, which is natural climate variability, while we're simply sitting at the top of an interglacial. All of this temperature changes at the peak of one of these cycles that I'm circling. That's it. That's humanity. And back up and look and see the real picture. Humanity is screwed on a regular basis.
Right. Well, and also look at the mean temperature of within the 100,000 year cycle. It's so far below the modern normal. So that's something else we have to consider.
Yeah, I would say it's probably 4 or 5 degrees C below the normal.
Right.
Somewhere in this range.
Right. Right. By the way, on this graph, why do they do this? Why do they have 2,000 thousands of years before present? That's so confusing. Why don't you just say 2 million in the chart,
It's a geology thing because we can quickly look and see 500,000, 1,000,000, 2 million, 2.5 million, 3 million.
It seems overly complicated to state your numbers that way.
And what's really exciting, if you're looking at this, you see how this portion here of 700, 800,000 years has color?
Yeah.
These are the ice cores from Vostok, the GISP 2. The rest is ocean sediment where they take cores way out there in the abyssal plain. But we are going to get more color all the way back to here.
Yeah. And that's because of the new, is it Antarctic ice core data? I can't remember.
Yeah, I would assume.
Yeah.
Or it could be Greenland.
Can't remember. That's one or the other. You can check it
Either
out on a
way,
previous
we're
show.
going to traverse that transition.
Yeah.
So maybe there'll be some really revealing proxy data in the ice, or maybe there'll be evidence of huge outbursts of the sun in the form of cosmogenic events, maybe
Mm-hmm.
cometary debris.
Mm-hmm.
So we need to get that data. It's very exciting that we're going to now have high resolution through that transition,
Mm-hmm.
through that time frame when that giant glacier grew, is right here, this deep hole of cold.
Yeah.
So it'll be fascinating when that data comes out.
Yeah. Yeah, definitely. I'm sure it'll take some time to find some of those markers, but if they're, assuming that they're there, I mean, we'd have to assume that something cosmogenic happened for those markers to be there, obviously. And we don't, and that could be the case, right? But it also could be something like, a change in our sun from outside of our solar system that caused the shift. In which case we'll see some kind of marker, but it might be difficult to distinguish that from some other cosmogenic markers.
Yeah, this graph is amazing. I just found it.
Yeah.
Very high resolution.
Yeah. Well, and also you've got different sets of ice core data being brought together, and that's helpful as well.
It's also helpful to see that the ice core data matches the ocean sediment data. So that means that when we're looking deep into time, it's probably quite accurate.
Yes. Yes. And then it's interesting to think about, too, that, were we to try to get some even deeper, older data from the ocean sediments, that there would be a limit to how much we can get simply because the ocean floor is only so old.
Yeah, well, the Atlantic is over 220 million years old, so we may be able to get that amount of sediment data. The problem is that once you push the sediment to a certain depth and pressure, it then lithifies and becomes rock. So anything that's 100 million year old sediment is definitely now rock, probably. And so you can't get that same type of data from the raw sediment. And you froze up. Are you talking?
Yeah, I was for a second, but it was clear that we were frozen again.
So here's the point. It is the coldest on Earth that it has been in the last 5 million years. The glacial cycles we are in are massive and the most catastrophic they've ever been, with shifts of 15 degrees C. And it doesn't seem to be stopping anytime soon.
No.
And they're sucking carbon dioxide out of the atmosphere. I mean, we live in a loony bin.
Yep. Total loony bin. I mean, it's in light of this data right here, and I said this again and again and again, but clearly the forces at work that control our climate are so much larger in magnitude that anything human beings could probably ever do. It just becomes so obvious how much that impact outweighs us in the climate results. So this idea that we can somehow suck carbon dioxide out of the atmosphere and it's going to dramatically change things is completely ridiculous. But, we've also talked about this idea that perhaps, people like Bill Gates want to be able to take credit for the temperature dropping when it drops naturally.
Yeah, and if you suck carbon dioxide out of the atmosphere, the ocean just releases more to replace it.
Right. Find
Great
us
stuff.
tonight on Magnetic Reversal News at 8 p.m. Mountain Time on YouTube.
listening to Revolution Radio.